Здравейте, приятели! Вие отново сте с Robotics Strategy Forum. Добре дошли след обедната почивка, когато ще си говорим за умни решения. Тук при нас са нашите приятели от Haycad Infotech, които ще ни разкажат повече за умните решения и индустрията.
Здравейте! Аз се казвам Георги Бояджиев и накратко ще ви представя дейностите на Haycad Infotech. Преди всичко обаче искам да благодаря на организаторите за възможността да участвам в това събитие. Така, накратко за лекторите. Аз съм инженер Георги Бояджиев, както вече разбрахте, и съм Solution архитект в фирма Haycad Infotech. Аз занимавам с внедряването на инженерни и бизнес решения, както и проучване на пазара с цел идентифициране на потенциални фирми, ползватели на нашите решения. Колегата Дамяно Нарди от Dassault Systems е специалист по управление на жизнения цикъл на изделията, като негови основен фокус е дигитални двойници, роботика и симулиране на виртуални производствени процеси. Относно темата, ще си говорим за комплексни решения за управление на жизнения цикъл на изделията и възможността за създаване на дигитални двойници в платформата 3D Experience. В допълнение ще си поговорим за продуктовата линия DELMIA и в частност DELMIA Robotics. Сега ще кажа накратко за нашият партньор Dassault Systems. Dassault Systems е технологична фирма, съчетаваща наука и технологии. Dassault Systems е един от лидерите в създаването на инженерни и бизнес решения. Относно Haycad Infotech, Haycad е група от фирми, разделена в две основни направления. Haycad Engineering с основен фокус предоставяне на инженерни и бизнес консултации и Haycad Infotech, официален партньор на Dassault Systems за решенията от висок клас, като например CATIA, продуктовата линия на DELMIA, 3D Experience, Simulия и други. От около 2 години създаваме едно трето направление – инженерна академия, така наречената Haycad Academy. Нашият слоган в Haycad Academy е, че ние създаваме инженерите на бъдещето. За последните 2 години създадохме над 12 целеви инженерни обучения, предимно за машинни инженери и инженери по автоматизация. Като в бъдеще планираме да разшириме нашето портфолио с обучения по роботика, 3D принтиране и всичко актуално, което изисква пазара. Тоест ние сме гъвкави, партнираме с всички инженерни учебни заведения и нашето портфолио от лектори и преподаватели е така доста обширно. Благодаря за вниманието. Сега давам думата на нашият колега от Италия, Дамяно Нарди. Ciao Damiano, can you hear me?
Yes, I do. Good morning.
Good morning. All right, good. The room is all yours. Good luck.
Okay, thank you very much. So first of all, let me share my screen. Okay, you should see my presentation.
Yeah.
Do you?
Yep, we confirm.
Okay, very good, very good. So, good morning to everyone. Thank you very much for hosting me. It's a pleasure to be here today in this very nice event in order to explain and introduce to you what we can offer as the system to support the Industry 4.0 and generally speaking, the robotics and virtual simulation topic. So as the colleague from Haycad anticipated, I'm Damiano Nardi and I work as a solution architect for Dassault Systems and I'm based in Italy. So I divided my presentation in 3 parts. We will have a short introduction, then I want to bring you some real examples in order to understand what we can do for you to support you in your digital transformation activities and projects. And we will conclude then with some customer references and some examples. So I would like to start our discussion from a couple of sentences that comes from the executive summary World Robotics of the last year. So this report says that after the crisis, okay, the market of the industrial robots will definitely grow in the next 3 years. So it's a very hot market in all the industries. So especially the electronics industries is growing very fast, but then also automotive is very strong, and also the metal, the machinery, the plastic. So we are seeing a strong adoption of industrial robots in many, many processes and many, many industries. And the other nice thing is that Central and Eastern Europe are expected to perform stronger than the Western Europe. So Europe is one of the biggest markets for industrial robots, actually the second after the Americas, and we expect to grow very fast in the next 3 years, especially in Central and Eastern Europe. So it means that all the companies that are involved in automation, like line builder, automation specialists, and so on, will face for sure many challenges in the next years. Like, for example, delivering flexible automated lines with the right level of performances, reduce the time to market, capture the best practice, and ensure what we call the digital continuity between all the stakeholders. So we mean the customer, the design guys, the manufacturing guys, and the service guys that are involved in the process. So as the System, we are here to help you facing these challenges. So what we can propose to you is, first of all, a tool that is called 3D Experience, as my colleague was introducing. So it's a business platform composed by a set of applications that help our customer in developing their product, from the design to the manufacturing and the service. So inside the 3D Experience, we have many apps that are branded like CATIA for the 3D modeling, Enovia for the data management, and we have, of course, the DELMIA application that are dedicated, generally speaking, to digital manufacturing, and in particular, for what we are going to see today, to robotics and virtual process simulations. But the very nice thing that I would like to underline is that all these applications live in the same database and are connected. So the CATIA guys, the DELMIA guys, the Simulia guys work in a unified environment in digital continuity. And this is very, very important to reduce non-added value activities and increase the collaboration. So the final goal of this application is to help our customer to build what we call the 3D Experience Twin. So in very few words, what is it? It's the virtual model, in this case of a production line, that can enable robotics companies, so they can be, again, line builder or automation department inside a manufacturing company, to first validate and optimize the line through simulations in the virtual world. So we are here in the left part of the slide. So it means that we will allow engineers to find and solve issues that are normally found in the real world. And of course, we know that solve issues in the real world will have a much higher cost. So the goal is really to test as much as possible in the virtual world, being sure that when we will pass to the physical one, okay, the mistakes will be minimum. But then we are also able, once the real production plan is working, to take the data, collect the data, and take them back to the virtual twin. So in this way, we can take data from the real world, and we can improve, and being sure that the next project, we will not do maybe some mistakes, and we will improve our design processes. Yeah, probably virtual twin is a term that you hear a lot. It's a sort of buzzword because everyone is talking about virtual twin. So that's nice, but I'm sure you are asking how can we do it, how we can achieve it. So what we can do is proposing as a System not only the tools to build the virtual twin, but also the methodologies to implement what we sell to you. So in case of this 3D Experience Twin, we can select what is needed to support your processes and improve the quality of the 3D Experience Twin according to your needs. So in this way, we will start step by step, maybe from the plant layout, then we will start doing more advanced simulation like robotics, discrete event simulation, virtual commissioning, so we can really increase the quality of the 3D Experience Twin according to what is your maturity state or what is needed in your project. And then the goal is, in time, to build a digital twin that will be very, very close to the real one. Again, to enable you to make a lot of simulations in the real world and avoid mistakes in the real one. So now I would like to share with you some examples. Okay, they are very practical and very simple, I hope. So these are clear examples of how we can apply our technology to real business processes and use cases. So the first example that I would like to share with you is an example in which we can show you how to build the layout of your production plant and how we can perform a robotic simulation. So when it is about robotic simulation, it means that you can adopt industrial robots from many suppliers like KUKA, ABB, Festo, Comau, whatever is the supplier, and we can take them into the platform with already the kinematics prepared to program them for many applications like spot welding, drilling and riveting, handling, laser cutting, painting, shot peening, flaming. So we can basically program every kind of robot from any supplier. So we are not specifically linked to a certain supplier. So we can program every kind of robot. And we can do it in an interactive 3D environment where the robot programmers can create, simulate, and validate the robotic cell. This is very important, and this is what we call the offline programming. So it means that you can program your robot in our tool, okay? And then once you are done, you can download the robot program in the native language of the robot, according, again, if it is KUKA, ABB, FANUC, and so on. And we will be able then to take this program in the real robot on the shop floor. And why this is very important? Because let's imagine that you want to improve the efficiency of an existing production line, or you want to launch a new product on an existing line. Well, if you do online programming, it means that you need to stop your line. It means that you need to perform online programming on site, and then you can start production again. But maybe you will lose 1 week, 2 weeks of production. In this way, you can keep producing with your existing line, and with our tool, you can simulate everything. And then instead of stopping the line for 2 weeks, you will stop it maybe for just a couple of days to perform the fine tuning. Okay. And this is very important and a very added value for every company that produces. So as we were saying before, the building of this 3D experience twin is a step-by-step project. So the first thing to do for sure will be building the 3D model of our 3D experience twin. So you can see here an example in which we have a full production plant composed by several work cells. We have work cells dedicated to spot welding, to painting, to machining, to shot peening, and so on. There are many robots, there are many equipments. And in this case, you see that now we are taking some items from a library. So in this case, we are putting an injection molding machine in our layout. So probably the first time you are going to build your plant layout, you will do it from scratch. But then, time to time, time by time, you will create your own library of equipments. And this will be very important because in this way, you will be able to capitalize the intellectual property of your company. So maybe once a new request from your customer will come, you will have a look at your library and you will select the closest one in terms of functionalities, in terms of requirements, and you will start from an existing one, reducing then the time to market and the engineering effort needed in order to design it. So that's one first important point. And secondly, as you can see here, once you have built your layout, you can start programming your robot. So in this case, you see we are using an industrial robot for the assembly of a car dashboard. So in this case, the goal is to ensure that the assembly happens without any clash. And the same we are seeing here for another application. In this case, it is spot welding. So we are using another robot from KUKA in this case. And we are studying basically the spot welding process. So also in this case, we will perform a reachability analysis, we will perform clash analysis, everything in virtual, being sure that it's fine. in order to avoid mistakes. And then we will download the robot program in the native language of the specific robot, ready to be uploaded on the shop floor. So this was the first example. The second one is a little bit more advanced, but I think it's very interesting because in this case, we are implementing what we call the virtual commissioning. Well, in few words, virtual commissioning means that we are able to virtually validate not only the kinematics, the clash, the reachability as we saw before, but also to control the full logic, the control logic of our manufacturing cell. So specifically, in the video we are seeing, we are studying how many sensors we need in our line and where we should place these sensors in the line. So automated lines right now have many sensors of many kind, and in this case they will be very important because they will detect work pieces and then they will trigger some specific robot task. So according to the kind of product, according to the product is okay or not, we will trigger many activities from the robot. So we will take the product maybe to the first conveyor or the second conveyor or the third one, according to what the sensor is reading. So really the goal is to enhance the capabilities of this kind of simulation, enabling concurrent engineering between the mechanical guys that will be maybe mainly focused on the robot programming, and the software expert and the automation guys that will instead focus on the study of the control software of the line. So in this case, we will be able to anticipate again possible mistakes, in this case related to the control logics, okay? And in this case, we will be able to reduce the on-site commissioning, that we know that it's very time and money consuming, because if we found some problems while we are doing commissioning on-site, maybe we need to come back and redesign something, so it will take a lot of time, and for sure our customer won't be happy. So these were a couple of examples that I prepared for you. And here is also a case study from one of our customers, Centerline in America. So Centerline is a company that produces work cell for many applications. So they adopted our tool in order to perform offline programming. And their experience says that they were able to reduce the issues and the rework on the shop floor by 90%, increasing the delivering on time and on budget of their projects. So in this case, we are seeing what we call a line builder that is using our tool in order to speed up and increase the efficiency of their selling of their production line, because they will sell faster and they will sell better because there will be less mistakes at customer site, and also their reputation will be higher. So this is one of example you can find also on YouTube if you are interested on listening the sound from the video, that I encourage to search on YouTube and see which is their testimony. So now coming from the conclusions, what we have seen so far is which is the context in which we are proposing you our tool, and we have seen some real-life examples that I hope clarify what we can do for you. So concluding, why to choose 3D experience for robotics and virtual process simulation? Well, first of all, we can offer to you a coverage of the full business process from the RFP to commissioning. And during all this process, we can ensure concurrent engineering between the different stakeholders, and we can avoid data duplication and inconsistencies that are typically non-added value activities. Also, as you saw, we can reduce the effort for on-site commissioning, and so we can speed up the time to market and save money. And one important thing that I would like to underline is that what you have seen so far is available also on the cloud as a software as a service. So there will be an easy deploy for you. And also the Dassault system spent a lot of time developing an ergonomic user interface to be easy to understand and easy to use in order to speed up the ramp-up process for the engineers that will use this tool. And so really the goal of the Dassault system is to support automation companies in the next year challenges with a modern platform and a proven methodology. And in this activity, of course, our local partner like Haycad for sure will help us. So thank you very much for your attention. I hope it was interesting. If you have any doubt or any comment, please contact me or the colleagues from Haycad. We will be very happy to answer to your questions.
Thank you very much for the pleasant presentation, Damiano.
You're welcome.
And see you soon in our next event. Thank you.
Yeah, it will be a pleasure.
Yeah.
Thank you very much.
Bye-bye.
Bye-bye.
Отново искам да благодаря за вниманието на всички. На екрана пред вас може да видите нашия вебсайт www.haycad-infotech.bg, където можете да намерите повече информация за нашите продукти и решения, както и контакти с нашите solution архитекти. Благодаря ви.